So now let's go into the mean, what we can do with these values. But first let's get to know what the mean is. Mean is basically the average of the entire data set that we have. This is the formula for it, where we add all the values and then divide it by the number of values which is there. Sigma here stands for the summation. And then after that we need to know what is the spread of that. For a given sample of data, once we have determined the mean, we'll also need to know the variance, that is how much different one value is with the other. So once we have the mean, what we do is this is the mean value, x bar is the mean value, and xi is the value of each of those sample data, and we deduct this mean from each of the sample data and square it and then sum them all. Squaring is so that we get rid of the negative values. This is then divided by the, if there are 10 values, n becomes the 10, n is the number of values minus 1, and that's when we get the entire variance. And because we have squared the numbers, this is a much bigger value. Basically here, as you can see, because we have squared, this is much more sensitive to outliers. That is, if there is a value of where there's a lot more on the either extreme of a curve, then it is very sensitive to it. That uses formula on that and square those values, and now the spread is a lot bigger. Now and this is just the variance. So what we do is we get the standard deviation to minimize that value, which is just the square root of that value, so that we get the minimum deviation which is there from the mean. That is how much distance is each value from the mean position of that sample data that we have. Now so basically this is a Gaussian distribution of how the data usually is. If we take height of some or height data of people, then this is how it usually is. It is also called a bell curve, where most people fall under the average height category. There are still very short people and so many tall people, and that is where we have this standard deviation and variance come in. If more people fall in very, very tall or very short categories, not like many people, even if there are few people with variance, there will be a lot of more spread on this. It will be much more broader. But if we take a standard deviation, we can have a lesser spread of this entire chart, and the bell can be very easily plotted with the mean in the middle.